G'day, this is Terry the Technician. Greetings from down under, and welcome to my Christmas 2020 special titled Did Santa Bring Your Blue Pill an Extra 64K Flash for Christmas? If you pop over to my website, you can see the address here, plus it'll be listed in the actual video comments anyway. You can see that I've made up a diagnostics program that can tell you whether or not the chip in your blue pill, which is a STM32F103R8, actually has an extra 64 kilobytes of flash, making a total of 128 KB of flash on board instead of the 64,000 bytes that the datasheet says it has and that all the standard programmers tell you it has. In other words, you just might have double the flash that you thought you had, and this program can tell you whether in fact you do. We jump back to my program. This is it here. You load it onto your blue pill board or any board with the same chip. It has the blue pill board has USB and so on. You just program it using your normal method that you use to program that board. The actual binary is on the website, and it's available freely for download. Here it is. Just download it, program it into the blue pill board. Okay, once you program it, you plug in a USB cable to your PC into the board. You connect up a serial terminal. That's just software. Linux has a ton of them. I'm using Picocom here, which is a Unix program. And when you power it up, you'll get the logon message, and when you hit enter, you'll get some OKs, like I'm getting here. This is the actual login prompt, which you don't need to know anything about. All you need to know is that you enter the question mark to get the menu, as you see here. And if you press M, you'll just get repeats of the menu. Pressing I gives you the ID of the chip. This is unique for every chip, and gives you the die coordinates, the wafer number. These are unique, and it gives you the ASCII lot numbers. This is all production stuff. No one really knows what this means, but it is unique for each chip. Now let's have a look at the device reported flash size. We press B for that, and here it is. This chip says that it officially only has 65,536 bytes, which is what we call 64K. So if you were just to look at this, or let your programmer look at this and decide how much flash you have on the chip, you'd think you only had 65K, right? In this case, wrong. This chip actually has 128K bytes of flash that you can use. Okay, so let's just have a quick look at the first 64K flash memory block. There are two. This one starts at hex 0 to hex 10,000, which is 64K. Let's just print it out. It's going to be pretty fast. You won't see much. You'll just see some text and stuff. That's actually my program running in the chip. So we press D to see that. Oops, sorry, we press E to see the first one. You can see there's all stuff on the left in ASCII. And if we just scroll up a bit, you can see there's some of that text menu. That was all right here. Now let's look at the second 64K flash memory block. We get that by pressing D. Oh look, it's all Fs. Now this in itself doesn't really mean that we've got another 64K block. It could just mean that when we read these memory locations, we just see FFs. It doesn't mean we can program them. Fortunately, this little test program can program them and then read them Let's do that now. We do that by pressing T for test. Oops. Here we go, yep. Testing the 64K flash block, erasing flash. So what it did, it erased this block. It flashed it with AAs, which is just a repeating sequence of ones and zeros. It then tested each location, found them all okay. It erased them. After the erasure, it checked to see that they were erased. It then flashed with 55, which is, it's flashing every bit in between every other bit above for AA. It then tested every location for 55, found they're all okay, then it erased them. So in fact, this chip has two 64K blocks. The first one holds this program. The second one is currently fully erased. And you can actually access and flash both blocks, which is double the memory you thought you had. If you have one of these chips, and if you have a blue pill like this picture above, or any of the similar boards with the same chip, and it passes this test, then Santa definitely bought you an extra 64K of flash for Christmas.